Good day, everyone. My name is Mildred, and today is the last day of the training workshop for the database source code and configuration structure training workshop. On Monday, we start the end user trainings. So for those of you that are program managers of focal points here, an email will go out before the close of working day today to await instructions for the accounts for all the other users that should join the trainings from next week. Today we are going to look at the data and the encryption. It is not a whole length of training. We're just wrapping up everything we have discussed from Monday until now. We are going to look at the type of encryption used, how we set the encryption keys and the block size, and then we're going to just run through everything we've discussed to round up this session, and hopefully the videos remain available for many years to come. Anytime you need those resources or information, you'll be able to get them. So I'll add, I think, yesterday and today's video recording to the final email I'll send later today. The system, case-based surveillance system, consists of two systems that we've said and an API. We have the patient management and reporting system, and then we have the virtual training workshop portal. Both of these systems collect information about clients and about users. The user's information doesn't really have too many sensitive information apart from the table that holds the account creation information that collects the names and the email addresses for the users. But the patient management and reporting system has too much personally identifiable information. This data needs to be secured and it needs to be de-identified before it is transported and even when it's at rest. And the purpose of this is to prevent sensitive records from being exposed, and also to prevent identity theft and all that if the data leaks. We have two types of encryption. We have the symmetric encryption and the asymmetric encryption. So the symmetric encryption is like the olden days encryption that when we write letters and we code, the person on the other end knows what the symbols and alphabet means to decrypt that information, to know exactly what the letter is talking about. It's an ancient way of encrypting. And then we have the asymmetric, which is modern, but takes too much CPU and resources. Although symmetric is ancient, it is most widely used and the strongest type of encryption that we have today. The case-based surveillance system uses a symmetric encryption, where only one key is used to both encrypt and decrypt information. That symmetric encryption has two types of algorithm. We have the block algorithm, which is what I use to encrypt the data, and then we have the stream algorithm, but I did not use the stream. Symmetric encryption is significantly fast and it is more efficient, and so the reason for the choice. Let's look at some parts of the source code to see how data is encrypted. In our environment file, we have two variables named input key and we have block size. These are the two variables responsible for the encryption of the data. Whatever you set as the input key is the secret key used for the encryption. Whatever we set as the block size is going to be the number of bits key length that is used for the encryption. The advanced encryption standard, which is what I used, is a symmetric block cipher algorithm, and it's both encrypts and decrypts using the same block size and input key. The United States National Institute for Standards and Technology has established this since 2002, I think, and is considered the most secure encryption known to be secured against all known attacks, actually. So how it works is that the secret key scrambles the data into an unreadable format. Once that scrambling is complete, we call the data, or the text we get out of it, the ciphertext. And when we decrypt back that ciphertext to the original, that is what we call the plaintext. To use this kind of standard, both the sender and the receiver must have knowledge of the key. So in the environment file, the input key and the block size are set. The input key is the secret key. The block size is the number of bits that we want to use, the bit key length we want to use for the encryption. AES has 128-bit key length, we have 192-bit key length, and we have 256-bit key length. How they differ is just in their strength. But even the least strength of AES has never been attacked or cannot be attacked. And this is the highest military-grade encryption that is used by the US government to encrypt all sensitive or classified information. And so our data is super safe, and no other layer of encryption is actually needed for the data in the database. There is a file here that is called aes.php. This is the file that holds all of the classes and the methods responsible for all of what happens for the data to be scrambled based on the secret key and the block size that is given. Whenever you set your secret key and your block size, and you have data that has been encrypted with this key and block size, that data can only ever be decrypted with the same secret key and block size. If you lose that secret key, then you will never get your plaintext back. So that is the reason why, or that is the reason you should never change your secret key when you have data in the system, or you make an arrangement to know that data from this period to this period uses this key, and data from maybe a new period uses a different key. So when it is time for the system to retrieve that record, you can actually retrieve them back in the plaintext. I will not even go through giving you any headache for the weekend to look at how this whole class works, but we're going to look at how we now use it. In the pages folder, we talked about having our init file in the include directory for all of them. This file holds require and include statements to require files or include files, and these files have the AES class already imported and initialized or instantiated. Whenever we want to save record in the database, the file that processes that data that is collected from the form looks at that information and decides if it is a private information like names, addresses, and if it is, it passes it through the encrypt function that is called in the header files. If it is trying to retrieve this data from the database and it is a sensitive information, it assumes that this has been encrypted previously and it tries to decrypt the information before presenting on the interface. So what you see on the interface is always your plain text. You don't know what has happened between going to save it and retrieving it back. Let us create a new client account and let us see how this encryption happens. So to create a new account for a new client, we just enter the values, and we're going to walk through all of this in next week's training about the end user, during the end user training workshop. So I'll just create this, let's say contact. I'll just put the facility type, let's say emergency room, the first name of this client, let's say Jane, the last name Doe, the date of birth, that's the 1st of March 2001, and the sex, let's say intersex, the mother's maiden name, let's say David. The testing code is generated. I want to use the testing code as the unique ID, and I'll write this down so that I will use this ID. So it's JDD01I, and the type is generated testing code. Okay, we have filled this form and we have saved it. This is the file that is responsible for displaying the form that we just filled. This file is processed by a file called the insert text. This insert text file now extracts all of the information. Notice that on this form, we have the name of the reporter to be the name of the person who is logged in. For it to display this, it has to actually pull out from the session who is logged in for it to say the logged in person is the person who is reporting this case. And so it just puts the name there. We don't have control over that. So every time somebody is trying to enter a record, that record is going to be timestamped, and also the created by will be filled by the name of the person who was logged in, or the account from which that record was entered. For it to display that name, it goes through looking at the session for the first and last name of the person logged in, and then it has to decrypt it, because everything that has to do with sensitive information is assumed to be encrypted. They are encrypted, and so the system just assumes that this is sensitive and this is encrypted. So the first thing you need to do is to pass that through the decrypt function, or to call the decrypt function. Once it is decrypted, they will now see it in plain text on the interface. Now, when all of the data that is entered into that form is extracted and stored in variables like this, it now looks at each of the sensitive information like the first name. Look at it and say if this first name has been entered, if the first name is set, then you want to encrypt it. But if not, just submit it as an empty, no first name was given. But if it is, extract that first name, specify the input key and the block size. We are getting this input key and block size from the settings file that is included here, and the settings file is getting it from the environment file and what it is set. When you pass it, when you supply the input key and the block size, then that first name is encrypted. And then when we want to now send it to the database, we are not going to be sending the first name that was entered here. We are going to be sending the first N, which is the encrypted one. And so when you see where we start the insert operation here, we start inserting the first name, last name. What we now insert is the encrypted value. So at no point does sensitive information actually leave the computer of the person entering the record. As soon as you click submit, then everything is encrypted before it even goes over the network. There is no risk of data exposure. There's no risk of hacking of your data. There is no risk of exposure of patient record as far as case-based surveillance system is concerned, until we get an announcement from the NIS or from the NIST that AES is no longer a secure standard. We have no risk of data breach. Let's go to the database table where this is stored. So it's the testing table. And the unique ID we used was JDD01I. So let's look for that client, JDD01I. So we look here to see everything that has to do with names. You can see that it is not in plain text. The first name of the client entered is not in plain text. The last name is not in plain text. We have the mother's maiden name is not in plain text. And then we see this information all encrypted. And then we know that when you export records from the database table to anybody that needs the data, your records are already by default de-identified. And you have no risk of saying somebody accessed the data, or the people in IT have access to the database, their patient record in it, and they can see people's names and people's medical history or conditions. No, it is not possible. The only way to view names and information is when you log in through the interface. And as you request the login or you click on your submit button, the system just converts ciphertext to plain text to present to you what you can understand. And once you log out, there is no plain text anywhere on the system for you to find out what the original text is actually is supposed to be. Another thing we will do in the coming week is to encrypt all of the clinical notes. And the reason we did not do that at first is to see how the in-country resources will work. But so far, it seems like the network and the servers are working well within countries, and we'll consider encrypting clinical notes. So those are the heaviest notes in the system, or text. And while it does not directly identify anyone, you just want to be super protected that most of these notes are scanned in, and you have the doctor's name and signature and whatever it is that is written there, even if there are no names of patients on those notes. All right. Does anyone have any question? All right, so that question always comes up too frequently about data security, and it always comes up about de-identifying information when there are all these meetings with external partners. So you all know the answer already now, and you know that there's no plain text as it regards to patient identity. Now let's go back and recap the whole process in one go so that we can refresh and finalize the whole agenda of this training. The case-based surveillance system has 7 modules. 3 modules control the patient management and reporting system, and 4 modules control the virtual training workshop platform. Now, there is this confusion about the training system, the virtual workshop system and the live system. When I send an email to say your account for joining virtual training workshop has been created, you have an account on the virtual training workshop platform. When an account is created for you on the pilot system for you to test and practice how to enter patient record for the end users, you have an account on the patient management and reporting system, but not on the live system. On the live system, it's only used within countries when you're entering real patient records. The pilot system has the site where people can go and practice, where we do the training workshop and you practice how to enter records correctly over and over again. Practices are not done on the live so that we don't affect the correct number and statistics of everything that goes on there for real life situations. So everybody who uses this system will end up with 2 accounts. One for the virtual training workshop platform where all the certifications and schedule, just like you joined today, exist, and the other is the test system where we'll do end user test and practice for the systems. The administration module is the module of the patient management and reporting system. It controls all of the configurations, user account settings, client accounts, recoveries, managing accounts generally. The way the module is structured, it has an includes folder that has all of the important header files that should be specified on all control pages. It has a script folder that holds all of the scripts for validation of input for all of the files that exist within the module. The files are named just close to what kind of form or function it performs. It will give you an idea. Sometimes the names are not exactly what it's supposed to, what the form holds or what that page holds, but it just gives you an idea of what it is. The fastest way to know the page that you are on or a problematic page is to look here at the interface and look at the last thing after the / You know that this is the page. You can see the directory where it is in. It's from the screening and management module, and this is the file that is controlling this page. And you can come back there to see that is the file that controls the page and look for that file in the events that you get an error on that page. So this is majorly for IT. When you need support, you can actually easily report the page where you have problems. You can copy this link and paste it in an email to say, I was on this page when I had this error come up, and then they immediately know what file to look at, even without looking at the error logs. We have another module for the patient management and reporting system, which is the screenings and management module, which consists of several forms and the major functionalities of the system. The files again are named similar to the functions that they perform. When we have things like insert before a name, like insert test, it means that particular processing script will be processing an insert operation to send new records into the database table. When we see anything that has an update as a prefix, we know that this is going to update existing information. It's a processing file to update existing information. We have the last module for the patient management and reporting system, which is the monitoring and reporting module. This controls all of the surveillance functionality. All of the reports you see automatically generated is controlled by all of the files that exist in this module. Again, the files are named close to what kind of reports you expect to find with that file, or what reports these files control. Then for the virtual training workshop platform, we have the developer module, which is like the administrator for that platform. Its functionalities are also listed, and the files are named close to what they do. So the functionalities are to create and manage users' accounts, and also create new training workshops, to be also able to supervise and view facilitators' configurations, and also view participant schedule. We have the facilitator module that controls all of the training workshop sessions, and creating session rooms, and adding participants to training workshops, and setting certification exams, and all of those assessments. The files here are also named close to the functions that those files control. Then we have the guest, that is just like a participant, and we see these participants is just all of the people who attend the training workshop, who logs in to view their schedule and see what it is how to join meetings, who are able to take certification assessments. These are the participants. The guest is like the participants, but without the assessment. The guest can only just join workshop and view and supervise, and guests are maybe any external partners that you invite for the training workshop, and all they need to do is to join and see what is going on, with no other functionalities. We have the API, and we're going to have the training workshop for the API on a different date, so I'm not even going to go into that. The API training workshop holds from November 11th to 15th. That is the last module that is technical for IT, and that is going to show us how other systems can request information or communicate with the ECBS system to get information out. Okay, so this is a summary of the case-based surveillance system on the technical part. Does anyone have any questions or clarification? Because this is the end of this training workshop series. So this is the time where you want to ask questions about your configurations, your validation, and your anything about the source code that you might have. So questions? All right, so in the absence of questions, this is the end of the workshop. I will send one final email after the afternoon sessions, and you will get the links to all of the videos for future references. Thank you, and see you all next week for those joining the end user training workshops.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you, Mildred.